This is John Allison from Arkansas A&M, and I'm here to present my solutions to the AP Precalculus Released FRQs from 2025. Remember, I work these cold so that I can kind of get a feel for how my students feel on those. And I'm going to start with Released FRQ number 1. And so we're going to set up the document camera. We're going to go to FRQ number 1. There we go. Okay. This is my first time to look at this. I have problem number 1. Make sure you can see this real quick. Okay, that's what you can. We're given a table and we're given a polynomial function. I'm going to go ahead and put this table here. I would probably not recopy this table if on the exam, but since I'm doing this video so you can see. Fine. And we're given a polynomial function g of x. Part A1, we are given that the function 8. I'll recall that I don't post the actual problem on here because College Board considers that a breach of its copyright protections. And so I'm going to include a link in the description of the video that you can go to and their website and access the release problems so that you can see and follow along if you view this. So we're asked to find the value of h of 1 as a decimal approximation. And so h of 1 is g of f of 1, which is going to be g of f of 1 is 1.75. And since this is on the calculator portion of the exam, we are going to turn to our calculator, which I have online here. And I am going to go ahead and type this in using 1.75 in place of x. I'll type it in the calculator. And make sure that I have it typed correctly. And I'm going to get 0.333. I need 3 decimal accuracy. I can go past that, or I can round or chop. This would round down, so I could not put 0.0334 on here and get the correct answer without a decimal presentation error. And we'll double check, make sure I answered the question fully. Show the work it leads to your answer. That was added this year. Good. So on part A2, we're asked to find f inverse of 3.5 or indicate that it is not defined. Because f is an decreasing function, I probably would not write this on there since it didn't ask for it. But because f is decreasing, so f inverse exists, and because f of 0 equals 3.5 from the table, we know f inverse of 3.5 equals 0. And that's part A2. Part B1, find all values of x as decimal approximations for which g of x equals 0. G of x is a cubic polynomial, so we know it has at most 3 real zeros. We're going to go to the graph, and we're going to type that in. We're going to graph it. And I would not sketch this. Maybe I would. But we're going to see a graph that looks like this with 3 zeros. What we expected because it's got a negative leading coefficient of cubic polynomial. And so we're going to use the calculator to find out using the second trace 0. The left bound and right bound, we're going to bracket each of these. I'm going to start with the leftmost. The left bound to the left of it. Move to the right of it, set the right bound, and tell it to guess. And I get x is negative 1.233. That would round down, but I can go 3 decimals. I'm going to do the next one, second trace 0. Left bound just to the left of that 0. Don't have to get super close, but don't want to make too many zeros in between the left bound and right bound. And I get x equals 1.578. That again would round down, so we don't want to mess that up. Second trace 0. Do our third on the calculator. Set our left bound and our right bound. Tell the calculator to guess. And I get x equals 5.643. That looks like part B1. Let's do part B2. Determine the end behavior of G as x increases without bounds. So we can see that as x goes to infinity, G of x goes to negative infinity. So then we can say the end behavior of G is the limit as x goes to infinity of G of x equals negative infinity. Then we'll look at part C1. Based on the table, which of the following function types best model the function f, linear, quadratic, exponential, or logarithmic? And we see that on equal length input intervals, consecutive equal length input intervals, the function value is being multiplied by 1/2 to get to the next function value. So that means there's a common ratio. That means that we have an exponential function because output values are proportional. So this is going to be an exponential function. Exponential decay function if we want to know. So we're going to say exponential model. And then part C2 asks us to explain and give a reason for our part. And based on the relationship between the change in the output values of f and the change in the input values of f. So we're going to say on consecutive equal length input value intervals, the change in output value intervals, or in output values, is proportional each subsequent output value is 1/2 the previous. Output value on these. input value. That may be a little wordy, but let's get us through question 1. And we'll do question 2 next. But we're going to make a video for each one of these.